we're looking at indeterminate form of 1 to power infinity, 0 to power 0, infinity to power 0. So in this case now, we can't use L'Hopital immediately. We need to do little algebra so that we can transform this indeterminate form to 0 over 0 or infinity over infinity. How do we do that? And that is what I'm going to discuss in this video. I'm going to back it up with questions. Look at this question with illustration we have here. Limit of f of x power g of x as x tends to a. If you do your direct substitute, we expect this to be of the form of any of this. What do we do? Very simple answer. What we're going to do is to transform this expression as this to exponential form. You'll be wondering, how did I know? It's not a magic. I'm going to show to us how I get this expression. Automatically, they are the same thing. But let's see how we transform these to this. What you do is very simple. Just call this one, let's y. Let it be equal to this. Then the next thing to do is to take the natural logarithm of both sides of the equation. So you have ln of y, ln f of x to power what? G of x equal to, according to the rules of logarithm, you have g of x. Then don't forget that ln, natural logarithm, is the same as logarithm to base e. And if you apply the rules again, you are going to have y. So all this expression will be on top of this. So y is equal to what? E to power g of x ln f of x. So I've shown that this same function is the same as that. Okay? So by the time you get acquainted to solving question, you would automatically know that this is this. Then the next thing to do now, since we have established that this is this, okay, the next thing to do is to, let's have a L. Let it be equal to limits of this power. Limit of that power as x tends to a. That will be limits as x tends to a of f of x all over 1 over g of x. So this one and this one, they are the same thing. You just little algebra. Okay, that's what we have done here. So by the time you now substitute now, we achieve our target of either 0 over 0 or infinity over infinity. And that's the target of this work. Then after that, you apply your L'Hopital rule. So that's that on these. Evaluate the following limits. The first one, if you substitute, we're going to have 0 over 0. This is limits of x to power x as x tends to 0 positive. This is just the right hand limits. Okay. So this is what we have. Then this is indeterminate form. So what I'm going to do now, let's y be equal to what? This. Take ln of both sides. If you do that, the power will come here. Okay. Then this ln is logarithm to power e of this. So y is equal to what? Y is equal to e. Okay. So we've established that limits as x tends to 0 positive of this function is equal to limits. So we've established that this function and this function, they are the same thing. Okay, and don't forget that e exponential is going to give you this function. Anytime you have exponential to ln of f of x, it's going to give you f of x. Okay. The next thing to do now is to take this one, call it L, take the limit of that as x tends to 0 positive of this function. So, and that will be equal to, we're going to play with this, okay? Because if you substitute this now, it's going to give you 0 dot infinity, okay? So we'll do the algebra, and that will be limits as x tends to 0 positive, ln x over what? 1 over x. So actually this also and this are the same thing. Don't forget that this is equal to 1 over x. Okay, and that's what we have done here. Then you can now plug in. If you now plug in now, you now have, this is 1 over 0, and that's infinity. And then natural logarithm of 0 is infinity. So we've achieved our targets. Then apply L'Hopital rule. Okay, and that will be equal to limits 0 positive. Differentiate your ln. That's if you have ln function, you differentiate this inner function, which is 1 over the function itself. Okay, over the denominator also do the same thing. Differentiate this one. That will be equal to what? Minus 1 over f squared. So you can do the algebra of this one, of this one here, 1 over x, and then flip this one times this negative here, s squared over 1. So this one we cancel. We have minus x over 1. So if you substitute, that will give you, if you substitute limits, so you're having now limits as x tends to 0 positive of minus x over 1 as equal to what? As equal to 0. So you now have limits as x tends to 0 positive of your function, this one, and that's equal to e to power l, and my l is what? 0. E to power 0, and that's what? That's 1. So that's that on this particular question. Okay. Please, if you are here for the first time and yet to subscribe, kindly smash the watermark on this video. Hit that notification bell so that anytime I upload, you get notified. Don't stop there. Click on like button and begin to type your comments. Finally, share the links of this video on all your social media platforms. Thank you for doing that.